Hello, we're doing a Edexcel January 13 vectors question in this video, which was done by Havant South Downs College, Havant Campus 2018, as a test they did. This was their question 1. I think it was question 7 from the actual paper in January 13. Anyway, the first bit's pretty standard stuff. The only thing is that I would say here is it's told us that they do meet, they do intersect. So that kind of takes some of the uncertainty out of it, and perhaps we might present it slightly differently, and we might get it done slightly quicker, given the fact that we know that they intersect. Anyway, let's rewrite this in this kind of combined form and column form, which I tend to use with vectors. So we're looking at line L1. The I component is 9 plus 1 lambda. The J component is 13 plus 4 lambda. And the K component is minus 3 minus 2 lambda. And looking at line L2, doing the same thing. The I component is 2I plus 2 mu. So that's 2 plus 2 mu. And the J component is minus 1 plus mu. And the K component is 1 plus mu. So we're told they meet, but we only really need to get two equations to equate them. So if we equate the I, we get 9 plus lambda is equal to 2 plus 2 mu. So that gives me lambda equals to 2 mu minus 7. And if we look at the J component, we get 13 plus 4 lambda is equal to minus 1 plus mu. If we arrange that, we get 4 lambda is equal to minus 14 plus mu. And substitute for lambda. You might not have solved in this way, of course. You can solve in all kinds of different ways. We all know how to solve a simultaneous equation, I hope. 4 into that, 4 lambda, which is 2 mu minus 7, is equal to minus 14 plus mu. So that gives me 8 mu minus 28 is equal to minus 14 plus mu. That gives me 7 mu is equal to 14, so mu equals 2, and we know if mu is equal to 2, that lambda is equal to 2 times 2, take away 7, which is minus 3. So I would then, what I'd do at this point, say we didn't have to even consider the z, they're told that they meet. So I would just put into any one of these the values and check with the other one to find our point of intersection. So the point of intersection, the position vector of the point of intersection will be, so let's put 2 in here, so that's 11, and 13 plus 4, sorry, not 2, it's minus 3, sorry, minus 3 in here, that's 9 minus 3, that's 6, minus 3, 13 minus 4 times 3, that's 1, and minus 3 in here, that's minus 3, minus 2 times minus 3, so it's minus 3 plus 6, that's 3. And as a quick check, I would put mu is equal to 2 in here, 2 plus 2 times 2, which is 6, minus 1 plus 2, which is 1, and 1 plus 2 is 3. So we know we're right, so that's nice, easy 5 marks. As is the next bit. Now part B, it's all to do with the dot product that we need to use, and it was the acute angle. Remember, it's the direction vectors that we need. These are the fellows we want. This bit is irrelevant. It's actually what direction they're going in, of course, which will determine the angle in between. I'm just going to go straight to it without faffing about too much. The angle is A dot B of a mod A, mod B, where these are the two vectors that we're finding the angle between. If it turns out to be obtuse, because it could be, of course. It all depends on which way the direction vector is going. We're going to take away from 180. That's the way I normally go about this. So A dot B, that's the dot product, that's 1 times 2. 1 times 2 for the I bit, then plus 4 times 1 for the J bit, plus minus 2 times 1. All over. Now we're looking at the magnitude or the modulus of that. That's 1 squared plus 4 squared. I tend to ignore negatives, less to write in the calculator. We know that minus 2 squared is plus 3 squared. So that's that, times by these 2 squared plus 2 squared plus 1 squared plus 1 squared. So that comes to 4 over the square root of 21, square root of 6. And if we inverse cos that, we get theta is equal to 69.1. So the acute angle is 69.1. So as is often the case with these vectors questions for Edexcel, they normally some relatively routine marks to be had, and then something a little bit trickier towards the end. Right, so here we've got, first of all, we're dealing with line L1. Let's just do a diagram here. We have line L1, let's move it up a bit there. Let's make that line L1. And sum up a point which is not on the line, point, it says point A. Not on the line, let's make it, I don't know, let's make it there. Okay, and it's telling us that the point P is on the line such that it's perpendicular. That's not a good placement for it, is it? That's not perpendicular. Right, let's make this one a bit easier. So there's my point A, there's my point P. We know the position vector of A, and we want to find the position vector of B. Now we know the direction of P. If we go back to that, that's this number here, 1, 4, minus 2. So that's direction 1, 4, minus 2. Right, what would be useful is to actually write P as a general point on the line, and we're going to use this form that we had here. This thing here, 9 plus lambda, 13 plus 4 lambda, and minus 2 lambda. 9 plus lambda, 13 plus 4 lambda, and then finally minus 3 minus 2 lambda. So that's the point P. Okay, now the point A we're given here, that's 4, 16 minus 3. So how to do this? We want to we know A, we know that the vector equation of line L1, and we want to find the coordinate P. Now this is quite a neat little technique we use. We use the dot product, and we use the fact that the direction, if they're at right angles, the dot product of these two vectors, or any vector going in these two directions, will be equal to 0. Well, we know the direction of L1, it's 1, 4, minus 2. So if we can get an expression for the direction of AP, or PA, wouldn't make any difference here, then we can then use the dot product. So let's work out AP. Now AP is going to be equal to OP minus OA, or minus OA, because minus OA plus OP. Imagine you had an origin here, say you'd go against the arrow here and with the arrow here, so it's that way. So we've got minus OA, so that's minus 4 minus 16 plus 3 plus 9 plus lambda, 13 plus 4 lambda, and minus 13 minus 2 lambda. Just add these together, so that gives me 5 plus lambda minus 3 plus 4 lambda and 3 minus 2 lambda. So that's an expression. Obviously that's finding what AP is, but actually it depends on what position on the line, and we want the particular value of lambda where the dot product is equal to 0. And then once we've got the value of lambda, we're fine. Okay, so since they're perpendicular, that implies that AP dotted with the direction of the line L1, that's 1, 4 minus 2, equals to 0. So in other words, we know what AP is. It's 5 plus lambda minus 3 plus 4 lambda and minus 2 lambda dotted with 1, 4 minus 2 equals 0. That's going to give us an equation. So that's 5 plus lambda times by 1 plus minus 3 plus 4 lambda times by 4 and minus 2 lambda times by minus 2, which is 4 lambda, equals to 0. Okay, now we've done this, we've got 5 plus lambda minus 12 plus 16 lambda plus 4 lambda equals 0. That gives me 21 lambda equals to 7. So lambda equals to 1/3. So now all I have to do is put a third back into my general equation for the line L1 into this bit basically, which is of course the same as this bit, just written a bit more conveniently. So if I put lambda equals to 1/3 in here, I get OP equals to 28 over 3, 43 over 3, and minus 3 minus 2 times 1/3, which is going to be minus 11 over 3. Okay, now it's asked for the coordinate, I believe. I think you'd be okay with that, but it's asked for coordinates, so we better write it as coordinate form. 28 over 3, 43 over 3, and minus 11 over 3. Okay, so that's the first vectors question done. I'm going to follow up with a video, another couple of vectors questions shortly, but I'll upload this one now. I think the next one will be coming relatively shortly. Okay, bye.